Hi, thanks for joining me today. I'm Andy Lomerson from Vicarious Visions. Today we're going to talk about how the visual effects of the most recent Skylanders game, SuperChargers, were created. Besides utilizing a very talented group of VFX artists at VV, we also completely reworked our entire effects system from the ground up. I'm going to talk about in depth why we did that, how we did that, and go through several examples of how we used that new effects system to create the visual effects in SuperChargers. First, a bit about me. My title is art principal, but really I'm just an artist that knows and does a lot of things, which is a pretty good description of an effects artist. I've been in the games industry for about 16 years, and during that time period I've at least touched the effects systems of many game engines, probably a lot of ones you're familiar with as well. We're not going to do a compare or contrast of the VV effects system to those other game engines today, although that might be a cool thing for the future. As an effects artist, you have to know just about every tool and content creation pipeline in your game engine. It also helps to be technically savvy because there is often a lot of challenging tasks required to make effects look good, be meaningful for gameplay, and be performant. Those tasks can be aided or hampered by your effects system. So why are we here today? As you can see, SuperChargers was a very effects-heavy game. All the character abilities, the environment effects, and of course, a whole new class of effects with all the vehicles required a lot of effort and support. Here's a brief overview of what I'm going to talk about today. I'm going to start with how we arrived at Special Ops, which are the core of the new effects system. Here I'm going to get us on the same page with some terminology, then dive into the effects artist request that drove the development of the new system, and then go through the evolution of the operator-based effects system and tools. In the next section, working with the new system, we'll take a look at using the new system to create effects, advanced features of operators, and what the user experience is like. Then we'll move on to some in-game examples by taking apart some of the effects in Skylanders SuperChargers. We'll follow up with lessons learned from creating our new effects system, and finally I'll talk about what's next for effects at VV. To understand how Vicarious Visions arrived at our current effects system, we need to review a bit of history of our VFX past. Engineers at VV have a habit of naming things their own way, and just so we are all on the same page during this presentation, let's talk about a couple of effects terms you might hear me use. A particle in the VV effects system is referred to as an instance, as in an instance of what is defined to be emitted. And an emitter for us is called a primitive. The primitive emits instances of itself. In previous VV effects systems, primitives could be of a specific type that determined what was being emitted, so basically what visuals to display or what utility function to perform. Choosing a specific primitive type determined all the properties that would be available, some of which would be unique to that primitive type. Some example primitive types would be sprites, billboards, model, line, cylinder, decals, and sub-effects. At the end of development for Skylanders Swap Force, which used the primitive type effects system, we had a VFX artist post-mortem like you would expect. And of course, as you would expect, there was a huge list of pipeline improvements and feature requests generated. VFX artists never seem to be satisfied. Taking a high-level look at the issues the artist discussed, several areas of the workflow stood out as focal points. Primitive types had properties that were similar but not identical. That led to some confusion. For instance, a sprite and a line would have similar properties, spawn info, orientation, material, and color. However, they also had specialized properties that were not compatible. Because of this, it was not possible to switch from one primitive type to another, making it seem like they were not really sharing the same core concepts at the system level. Another major area of requested improvement was instance orientation. When looking for screenshots of the previous system, I found a quote that our technical writer subtitled the orientation section of the documentation. It was, "Be afraid, be very afraid." That is not good. We did have this short drop-down list of orientation presets that would just check off a lot of things for you and set up some axis values, but it was still hard to tell what was going on and very difficult to modify. The main problems with the orientation controls were every situation that the system could handle had to be exposed because of the fixed properties of primitive types. The exposed properties themselves were confusing. There was no way to control what order the orientation settings were going to be applied relative to the rest of the instance's properties. Do I want to orient first and apply motion or rotation? Because of this, it was impossible to get certain very specific orientations. Why is orientation so important? A lot of visual effects is representing 3D in volume using simple shapes such as 2D sprites. Being able to explicitly control the facing of these shapes is vital for that illusion. Another role is emulating other parts of the game engine, which a lot of times requires making things align in very specific ways. VFX artists at VV made pages of examples to show all the things we wanted to be able to do with orientation. Another area of feedback came from the inability to relate or sync elements of an effect together. It was hard to do stuff like use this color only slightly tinted, use this size only slightly larger, these two sprites move exactly the same way, and we still wanted random variation with all these relationships. In addition, we also had a huge headache when it came to effects budgets. Remember all those primitive types we talked about earlier? Each had their own memory budget with max numbers of instances and primitives as separate pools. Man, who decided only 51 models could be spawned at once in an environment in SwapForce? Also, all the budgets assumed worst case scenario, meaning if you weren't using, say, all the cylinders, your budget was still expecting them. You couldn't decide to use that extra unused part of the budget for more sprites. With issues documented and grouped, it was time to deep dive into solutions. As we know, solutions take resources, so VFX artists prioritized the list of requests and prepared to get maybe one or two of the issues addressed. Since the team placed such a high emphasis on making orientation easier to work with, the evolution of the effects system began there. We started with a simple demonstration of how we wanted to be able to explicitly describe an instance's orientation. First, point the instance's y-axis along the world's z-axis. Then point the instance's z-axis at the camera's position. Then translate forward a bit on the instance's z-axis. Graphics engineers at VV, specifically one AC Stapp, were already realizing that VFX artists wanted to tell the effects system exactly how to behave, not just for orientation, but for everything. The foundational idea was to specify exactly how an instance was to act and look with chunks of functionality called operators. For instance, following the same description from the previous slide, these are the operators that first align an instance's y-axis to the world z, then align the instance's z-axis to the camera's position, and then translate 25 units along the instance's z-axis. We were on our way. Every piece of functionality that was available in the previous system was broken down into a basic component and replicated as an operator. This included the final rendering of an instance with a draw operator, which, as it turns out, is basically the defining element of a primitive type. Because of the way the operator system was implemented by AC, it's relatively easy to add new operators and functionality to the core system instead of multiple times to each individual primitive type. Engineers were enabled to quickly add features that eclipsed our previous systems. The operators apply properties as they are evaluated to emitted instances in a specific order. The list of operators to apply and the order to apply them are known as the operator stack. VFX artists will only add operators to the stack for functionality that is needed by the instance, theoretically. The operator stack does allow more than one operator of the same type to be evaluated in the stack, which allows you to create some pretty interesting results, as we will see later in the examples. We developed a fully featured interface for working with the stack of operators called the stack graph. It started with my early mock-ups in Photoshop when the functionality of operators was still being worked out, and was implemented in a version we pretty much had all through SuperChargers, originally created by Frank Fella of Epic Games fame, to what we currently have, which has been thoroughly worked over by our tech/VFX artist Shay McCombs. Yes, those are tiny thumbnails of data on each operator. An important aspect of the operator stack is that it can have multiple tracks, allowing us to pass and modify properties and work with related data. The graphs present this in a very clear way. It's not as loose as a visual scripting system, but definitely way more feature-filled than a reorderable list. Another bonus is that stacks are mergeable. We will see plenty of the operator stack graph in action over the rest of the presentation. So how did the new operator system score addressing the list of VFX artist issues? Alignment is now separate and precise. An artist can specify any orientation with align operators that make sense. There is direct control over the order of operations. An artist can explicitly define the order in which properties are evaluated and applied to an instance. Different elements of the effect can be related. Because operators pass modified properties down the stack, it's possible to set up relationships between different parts of an effect. Operator stack primitives share budgets. There is no longer a large, confusing list of VFX budgets that fight with each other. There are still budgets to keep in mind, but they all work together for the most part. A couple of bonus issues also got resolved just by how the operator stack works. Switching primitive types. By switching the draw operator to a different kind, the operator stack will now render a different visual in-game. There is only one primitive type. Only properties that are used are exposed. A primitive is now created with only the properties that are required. When done correctly, this can simplify working with an effect greatly. So now we have this system based on building effects with operators. Did we really resolve all the things VFX artists were asking for? What's it like working with operators? This is Laboratory, Vicarious Visions' internal tool suite. Laboratory has layouts of specific panels designed for different workflows called builders. Lab could probably be an entire other presentation, so we're just going to focus on the parts that have to do with visual effects. This is the layout for the VFX builder, which contains the following panels: the operator stack graph, the properties tab, which shows the properties of two selected operators, the timeline, the effects explorer, the recent effects panel, and the control panel. Let's go through the process of making a simple effect. I have an effect with an operator primitive that starts off with a blank operator stack. So let's add some visuals in here so we can see what we're doing. Just added a draw sprite. And if you look closely, you can see there's the sprite right there, that small white dot. The initial values for an operator stack come from the bolt itself, and in this case the bolt has a size of 111, which the sprite sees as 1 inch by 1 inch. So let's give it a size operator, and let's start it at 150 inches. Okay, so there we go. We can see our sprite now. The normal of the sprite is facing along the z-axis, and our bolt's initial z-axis is pointing straight up. So we're looking at a flat sprite right now. Let's go back to our sprite and add a material. So we've got a texture of a film strip of clouds here. And I'm going to set that to be standard blended so the alphas work correctly. And I'm going to give it a material of lit smoke. So there we go. Alright, so we don't want to see all the clouds at the same time. So let's add a film strip operator. And this will allow me to tell the sprite how many rows and columns are in our film strip. And so now we just have one cloud. So the sprite is still facing up, so let's fix that. There's a lot of different ways to align a sprite, or an instance actually. So I'm going to use the align dual operator. So let's point the z-axis of our instance along the camera's z-axis, and the z-axis of the camera is coming straight out of it. And then let's align the y-axis of the instance towards the camera's y-axis, which comes out of the top of the camera. So there we go, we have a billboarded sprite. Let's give our sprite some velocity. And let's give it 100 inches per second along the z-axis, so it's moving up. So we like to see a few more sprites in our effect. So let's go in to the properties of our primitive, and let's change the spawn value to be spawn rate. So this is going to be instances per second. So let's make that 4. And let's also make the instances live a little bit longer for 4 seconds, so we can get some motion and some visuals in there for color and alpha as well. So right now, as soon as our instance is born, it pops in, and when it dies, it pops out, which isn't very graceful. So let's add a color curve in here. And I'm going to give it some alpha. And this is our color curve editor, or excuse me, our curve editor. And I can have some presets for my curve editor that I made before. And I'm going to use this one that I like to call Whale, which has a quick alpha in and then a ease alpha out. So there we go. We've got a when it's first born, it's fading in, and when it's dying, it's fading out. And let's change the color a little bit as well. So our color picker has the ability to have a lot of different images that you can pick from. So I just made these color swatches for what I wanted the smoke to be. So there's our first keyframe, is that light gray color. I'm gonna add a couple more keyframes in here. There's our second keyframe, a little bit darker. And then our final keyframe, pretty close to black. All right, so we can see that our instances are all basically rotated exactly the same, which kind of gets you this repeating pattern, which doesn't look very realistic. So let's go in after our align dual, and let's put in a rotate. And with the rotate, we're going to say after we align, rotate our instance anywhere from 0 to 360 degrees. And this isn't changing over time. This is just a range that the instance is going to choose from 0 to 360. So there we go. It's changing up a little bit. Another thing we can do to get a little bit of variation in there is go back to our film strip. So we have 8 different images in our film strip. So let's use all of them. So I'm going to say randomly choose any of the 8 frames here. So that is a range of 0 to 1. So now it's choosing any of those 8 film strip images. All right, let's go back to our size curve, and let's put a little bit of change over time in our size curve. So I'm going to expand that value out to be to use keyframe curves. So back into our curve editor, add a second keyframe here. Let's start off with having our instances start off pretty small at 50 inches and then go up to 400 inches. And then let's add another keyframe in here. Change it to a Bezier. So we'll start off small, kind of plane out here, and eventually expand. And let's get a little bit of variation in our size as well. So I'm going to select the keyframes and give them each a range. And I can adjust that range a little bit if I want. So there we go. We've got some variation going on in our size there. So the last thing we're going to do is let's put something that represents wind in here. So I'm going to do an acceleration directional range. And I want this to go along the x-axis. So when someone places this effect in the level, they'll be able to basically rotate the entity that this is spawned from, and they can point the x-axis towards which way the wind should go. So let's give the acceleration a range of 40, 50, and there we go. We've got a simple effect that has a lot going on, a lot of variation, and is also controllable if you rotate the bolt around. Speaking from experience, working with the operator stack can be fairly complex. Luckily, development of the system included many features directly related to supporting VFX artists with the new workflow. You can really only take advantage of a feature-rich VFX system if you can tell what you are doing. Obviously, with the operator stack, it becomes really important to understand exactly what's going on at every step. There are two major ways that we can break down a primitive with debugging assistance. We can enable and disable operators, and we can use a special type of draw operator called a debug frame. Any operator in the stack can be enabled or disabled. If an operator is disabled, the stack basically just skips over that evaluation and does not modify any values or draw any visuals. The second way to visualize what's going on in an operator stack is by using a special draw operator called a debug frame. This creates an axis that can show position, rotation, size, color, and even the velocity vector of the instance at any particular point in the stack. It's possible to have as many draw debug frames as you want in the stack, and you can drag the draw debug frames to a different location in the stack. Here we can see the results of the line dual operator, which aligns the instance's y-axis to the velocity vector. The draw operator can also show the instance's color at any point in the stack. Finally, if we enable the draw sprite operator, we can see how all the sprite's properties match up with the debug frame. One thing most effects artists know is that you will probably end up looking at another artist's work at some point in development. Also, sometimes you can get confused with your own stuff, especially if you're working with a very complicated operator stack. To help decipher artist effects, operator names and comments were added. As you can see, the name shows up right under the operator type in yellow. In addition, each operator has a comment field. If the operator has a comment entered, a little yellow dot will appear on the operator in the stack graph. And when you mouse over that operator, the comment shows up as a tooltip. While building effects that duplicate the functionality of our previous effects system is cool, we can also now create effects that were simply not possible before by taking advantage of the way the operator stack system works. In the creation example of the lit smoke effect we walked through, the operator stack is pretty straightforward. The operators are evaluated in order from the top of the stack to the bottom, and the values are applied to each instance spawned. The results are visualized with the draw sprite operator. This single path down the stack is called a track. An operator stack can actually have more than one track. It can have up to 4 tracks. Why would we need an effect with more than one track? We'll get to 4 tracks, but for now let's talk about just having more than one. An operator stack still represents all the properties that go into a single instance. However, the instance can have more than one draw operator and be using separate tracks to generate individual properties such as velocity, size, and color for each draw op. Basically, there is one instance that is drawing 2 independent visuals. They share the same instance life and spawn rate, so they're still related. However, more interesting uses for multiple tracks are operators that can use properties from other tracks. For instance, we can have an align operator that points at another stack's position. Instance frames allows us to set up which properties of a track are locked to the spawning bolt's properties. In this example, track 1 is being spawned at a fixed position, while track 2 is being spawned at and locked to another moving bolt, and is continuing to update using that bolt's position and orientation. The align operator in track 1 is causing the first draw model to track the other's location. This is one of the more complex draw operators, draw Bezier, which can use all 4 tracks, one for each end's position and one for each handle's position. The handles and endpoints could move completely independently, but in this case they are all related. You can see in this example that there are several track copy operators that allow us to pass values between tracks. The initial position is being passed down to each track. I can change the translate and all the tracks respond. The tracks then apply their own translate offset on top of that. The handles have transform animations. The color also has a randomly generated initial value which is passed to the other end's track. This is one way we solve the issue of related effects visuals. Another way the operator stack solves the issue of relating different visuals together is with modulation. Instead of always overriding a value when an operator is evaluated, the operator can instead modify or modulate the value based on a set of options, so the new value has some relationship to the old. Modulation options are modulate, add, subtract, divide, replace, which will just replace the instance's current value with whatever the operator generates, and keep, which doesn't modify the instance's current value at all. Let's walk down the stack of a simple example that uses modulation to relate two sprites together. VFX artists know that multiplying by color always knocks out any sort of hot white core. While there are lots of solutions for this, like a gradient remap material, this is an easy and practical way to illustrate how operators can be used together to form relationships between different visuals. This instance has a simple translate distance curve which moves the instances up. I then set the initial size from 200 to 300. I also have a size curve which scales the instances in and then back out. We've got an aligned billboard in here, and then a color curve which sets the initial color from purple to aqua. Then we draw our first sprite, which is going to be the background. I've got a translate distance fix in here just to separate the two elements so we can see what's going on. Then I take the initial size and scale it down by 40%. Then using the initial color, I'm going to lighten it a bit by adding gray. And then we draw the second sprite, which is our white hot core. If I turn off the translate distance fix, we can see the two elements together, and we can see that they're both related in size, motion, and color. A feature that came online later in development of SuperChargers was one that VFX artists at VV had been clamoring for, but really only became feasible in our effects system with the development of the operator stack. Pretty much all properties that are animated in our VFX were driven by time. The lifetime of the instance is remapped with a graph to a value that gets updated, like the property output in this image. But something we had always asked for was the ability to drive the property output by using an input other than time. And that's what curve inputs and track parameters gave us. The basic idea is that just about any curve can now be driven by a track parameter instead of time. The track parameter is a value from 0 to 1 and gets remapped with the curve to the output parameter. This works a lot like a curves adjustment layer in Photoshop. So, where do the input parameters come from? Each track has 4 extra track parameter values in addition to the standard values we've already discussed. These are like utility tracks that can be set in a number of ways. One way is with special operators that use properties of the instance or game elements to set or update the track parameters. Example properties are distance, planar distance, camera FOV, velocity, or angle between two tracks. This is an example that sets a parameter on track 1 using a curve input by distance operator based on the distance from track 1 to track 2. The track parameter is then used to drive the size and color of track 1. The closer the player gets to the effect, the larger and brighter the sprites become. This feature came online a bit later in SuperChargers development. The spawn rates of primitives can also be dynamically driven by curve inputs. Using the distance operator again, the spawn rate increases as the player gets closer to the effect. Among other uses, the ability to dynamically change a primitive spawn rate came in handy during optimization. Towards the end of SuperChargers, a lot of focus shifted towards optimization. And as we probably all know, VFX always need to go through optimization passes. Several operators came online to specifically address optimizing effects visuals, specifically camera fade, camera scale by range, camera fade and scale, and curve input lifetime scale. Without any optimization, the effect fills up the screen and has lots of overdraw. The camera scale by range operator causes the instances to scale down based on the distance of the camera to the instance. Camera fade operator will lower the alpha of the instance based on the distance to the camera. An instance with an alpha of 0 doesn't count as a draw call. SuperChargers had a whole new aspect this time around with vehicles. Particle emitters ended up being bolted to vehicles that could travel at speeds that ranged from very slow or even a dead stop to super fast speeds on some of the track sections. We already had functionality to dial up the number of instances spawned based on the distance the primitive traveled per frame. However, the same instance lifetime that looked good when the vehicle is traveling slow causes a lot of long-living instances to be left behind when the vehicle is traveling fast. This obviously eats into the effects budget with the number of instances that can be living. In the case of the track section, a lot of times you wouldn't even be able to see the instances that got left behind. Our solution was the curve input lifetime scale operator. This allowed us to scale the life of a particle based on anything that the curve inputs could use to drive them, but in most of the cases, with vehicles, the speed was used. Here we see a primitive moving pretty slowly and leaving a trail of instances behind. The primitive is using spawn by distance to get a pretty nice spread of instances no matter what the speed. However, if the speed of the primitive is increased without any lifetime scale, you can see that because of the spawn by distance, we just end up with a ton of instances on screen. Now, using the primitive's velocity to drive the lifetime scale, we can say the faster the bolt is moving, the shorter we want the instances to live. There is still a nice coverage of instances, about the same area as when the primitive was moving slower, we just aren't leaving a huge number behind, especially ones that end up off screen as a vehicle zips by. Our effect system has had this relatively remarkable feature in the past, which has become even more useful in the operator stack system. We call it intro, loop, outro. An effects timeline can have a section where each primitive will spawn once, the intro, followed by a section where the primitive will spawn until the effect is killed, the loop, followed by the last section where primitives will again spawn only once, the outro. This is very useful because you can stick everything into this single effect and you only have to hook one thing up in game. You don't need, say, a muzzle flash effect, a projectile effect hooked up in another place, followed by an impact effect spawned from yet another piece of game data. It all goes in one effect that is called in just one place. This in itself is pretty neat, but with operator stacks we get to take it even further. One of the input types that can drive a curve is the lifetime of the primitive, as opposed to the lifetime of the instance. Unlike the instance's lifetime, which can only go forward in time, the primitive's lifetime can move forward, loop over a period of time, and then move forward again because of the way the intro, loop, outro timeline works. This feature can be really useful when trying to get the size or UVs to line up when you have an effect that starts, has an indeterminate lifetime, and then needs to wrap up. It's hard to sync all these aspects with multiple primitives in the timeline, let alone separate effects. If you look at the beam primitive here, you can see that its life spans the intro, loop, and outro sections. By using the primitive's time as the curve input, the instance's size operator can have its own intro, loop, and outro. The smooth size up corresponds to the intro section, the flat size with no change is the looping section, and the smooth size down is the outro section. In action, it turns out like this. We have a single instance that can start up, loop for as long as it's needed, and then gracefully exit, and still maintain changing attributes like scrolling UVs. Let's take a look at some practical examples of using operators to create some effects that shift in SuperChargers. I'm going to be discussing 4 examples from 2 different vehicles. The first vehicle we're going to look at is called the Stealth Stinger, which is Stealth Elf's ride. As you can see, it is a copter that's made out of plants, because, well, it is. The copter has 2 unique abilities. First, it can go into stealth mode, turning invisible and evading enemies. Second are its twin tracking miniguns so it can blow stuff away. Let's look at stealth mode first. The effects that make up the stealth ability have a more traditional VFX construction and don't use a ton of advanced features of the operator stack, but it's still interesting to see how a more traditional setup is done with the new effect system. The ability has an intro where the copter basically disintegrates into leaves. It then goes into a looping section, which is this ghostly silhouette of the copter filled with miasma. Because the player could be in stealth mode a variable amount of time, the effect had to be able to loop indefinitely. Finally, the ability ends with an outro effect of the copter reforming from the leaves. Looking at just the intro, we have the appearance of the ghost shell and the leaves falling away. The falling leaves is really the core component of this intro effect. This is achieved by spawning the leaves in a half ring around the chopper. I wanted a lot of control about where the leaves would spawn so they would be evenly distributed and I wouldn't lose a lot of them spawning at the bottom. We can spawn instances off the verts of a mesh in the direction of the normals, so I created a half ring with the normals pointing out. I also wanted the leaves to look like they were peeling away from the front to the back of the copter. This is achieved by moving the spawn location, my spawn mesh, from the front to the back of the copter body. So while the spawn location is bolted to the copter, it's also translating from front to back. The moving mesh spawn emitter is actually a parent effect that spawns the leaves as children, a sub-effect. That way, the emitter is bolted to the vehicle while the leaves are free to fall away. The motion of the leaves is controlled by a couple of things. They have an initial velocity that flings them out away from the copter body in the direction of the spawn mesh normals. They also inherit a portion of the copter's velocity, so they move along with the copter. Then, the gravity operator pulls the leaves down. To really sell the leaves peeling away, I didn't want the leaves to just look like they were falling away with random rotation and orientation. I used an align operator to orient one axis of the leaves towards the velocity. I don't want to align both axes because I use a rotate operator to rotate the leaves back over time, which causes them to peel away. It's easier to see the rotation if we look at just one of the leaf clusters, which is a model with 3 slightly different sized leaves. And now here's the sequence of the copter in flight. I feel like I was able to sell the copter falling apart into leaves as it flies, with the multiple layers of motion. Let's move on to the tracking guns of the Stealth Stinger. Originally, the copter had only one minigun, but it was under the body. When the gun was firing, most of the muzzle flash was hidden by the body of the copter. I thought it would be way more rewarding to the player to be able to see the guns blasting away, so I suggested that they be moved to mounts on either side of the vehicle. The only problem with that was the vehicles and superchargers have auto-tracking projectiles, and you would now see that the guns were pointing one way and the projectiles going another. We didn't have the resources to put in another game system, especially just for one out of the 20 vehicles. Luckily, you can do just about anything with the operator stack. The miniguns themselves were effects designed to point at the vehicle's target. However, the vehicle wasn't always locked on a target, and when it did, the lock was instantaneous. So the guns could not just continuously point at whatever the game thought the target position was, or that would cause a lot of orientation snapping, which looked pretty terrible. Instead, I created the effect to allow the tracking guns to move smoothly as they locked on the targets, switched targets, or disengaged. Here's the basic setup of the tracking gun effect. What each track is locked to is really important to get everything working correctly. Bolt 1 is the mounting point of the gun on the copter's rig and can be animated by an animator. Bolt 2 is the procedural game-driven target location. Track 1 is the VFX gun attached to the copter's bolt. Tracks 2 and 3 are for debugging certain aspects of the setup. Track 4 is an instance that chases the game-driven target location. There are 2 primitives in the timeline because in some menus there is nothing for the guns to track and they will break. Scripting makes sure the right primitive is active. Track 4 is really where the magic happens. When the game creates the copter, the effect spawns. The translate distant fixed automatically starts the instance a far distance away from the copter, close to the undefined target point. The align single continuously points the instance, what I call the target chaser, at the game-driven target point. The curve input by distance continuously sets track 4's input parameter 1, based on the distance track 4 is from the target point. This will be a value from 1 to 0. If the distance is 5,000 inches or more, the value is 1. As the input parameter is updated by the by-distance operator above, the velocity direction speed curve increases or decreases the velocity of the target chaser. The speed is quite high at max distance and then planes off a bit as the chaser closes in on the target. Now back to track 1, which is actually drawing the minigun visuals with the draw model operator. This is using an align dual operator to point the gun model's barrel towards the target chaser's position. Constrained to that alignment, the operator also aligns the z-axis of the model to the z-axis of the bolt. This will allow the model to still take animation coming from the copter's rig. Here's the tracking guns in action with the debug model showing what the target chaser, Track 4, is doing. Put it all together with some muzzle flashes, tracers, and acorn top shell casings, and Stealth Stinger has got some miniguns hopefully people can appreciate. Let's investigate some of the effects for Thump Truck, an angry construction vehicle really only designed to wreck stuff. I added boulders spilling out of the back of one of Thump Truck's mods that the player can interact with. It looks like a game system, but is really done completely through VFX. On another one of the truck's mods, a wrecking ball that swings around mixes physics-driven animation with VFX to spawn sparks whenever the ball collides with the vehicle's frame. This interaction is also handled entirely by the operator stack. The deep bucket bed is full of physics boulders that try to be smart about how many are active at once. The boulders have an infinite life within a certain radius to the vehicle, so as long as the player is interacting with them, they will stick around. The spawn rate is set to keep the number of debris constant, but not just pop a bunch of them into the truck bed at once. Also, there is some hackery to get different debris looks, including a rare gem that appears every so often. The spawn rate info is where the max number of 4 boulders is set. Also, the spawn rate curve is being driven by the vehicle's speed. No new boulders will spawn while the truck is stopped, and the rate increases as the vehicle speeds up. You'll probably be losing a lot of boulders out of the back as you race around. The lifetime of the boulder is controlled by 2 operators, the curve input by distance and the lifetime scale operators. You remember that the boulder actually spawns with an infinite life. However, the curve input by distance sets a track parameter to 1 when the boulder is 1500 inches or more from the truck. The lifetime scale is driven by that track parameter, and when the value is 1, the instance's life scales to 0 and is removed. The same track parameter set by the distance is also used to drive the boulder's alpha, so it fades out before it dies. The boulder will actually fade back in if you turn the vehicle around and drive towards it. The boulder can spawn in with 5 different looks. The curve input random at the top of the stack seeds a track parameter with a random value. The curve input step takes the random value and clamps it to 5 specific values from 0 to 1. Those values correspond to the color gradient here. The color will only be one of the keyframes. It will never fall in the gradient because of the step. Finally, if the value happens to be 1, the first draw model operator won't draw because it will get a 0 alpha. That way the second draw model operator will appear, which is the rarely seen blue gem. Well, 1 in 5 chance. This is the old ball and chain mod for Thump Truck. Yes, it's really called that. When the ball, which is driven by physics, swings into the frame, a VFX fires off some sparks. There weren't enough resources available to get custom collision events for this one vehicle's mod, so I used the functionality of the operator stack to get something that works pretty well. The core of the effect is using the distance between 2 bolts to drive the spawn rate of the spark effect. Turning on some debug frames allows us to see the positions that are being used to calculate the distance. There's one position attached to the center of the ball and 2 others attached to the left and right of the frame. This is the op stack, which sets up the position of the 3 locations and then uses 2 separate curve input by distance operators to test the distance between the free swinging wrecking ball and the 2 fixed positions. Those operators generate track parameters that get passed to 2 separate instances of the child sparking effect spawned by the draw sub-effect operators. The spawn info of the sparking child effect, seen here, takes the passed-in parameter and uses it to drive a spawn rate. When the distance is really small, the spawn rate is very high. The distance will only be small for short periods of time as the ball will swing back the other way. This creates a quick shower of sparks, which seems like it's happening because of collision, but really it's because of the small distance between the ball and one of the fixed positions. Let's take a quick look at some unexpected ways we ended up using the operator stack. I like to call effects can be anything. Because of being able to pass values into and between operator stacks, it's really nice to be able to use VFX to display HUD-like indicators of values. Also, by using several different curve input by and some input parameters, I was able to make a pretty convincing minimap drawn solely by the effects system. Vehicles and superchargers could send effects a value that represented the vehicle's current speed and a value that represented the vehicle's throttle, basically how far down the gas pedal was. Sometimes you wanted to know if your effect was even receiving these values, and knowing what the change or extent of the values were while driving was very useful for making adjustments so effects look correct at various speeds. I made several in-game gauges that could be thrown onto an effect which indicated the current values of speed and throttle. These were attached to the camera and driven with curve inputs to give visual feedback. It probably could have been done with debug text, but I think the feedback the visual gauges gave was more valuable. For a gameplay concept, I wanted to make a mini-map. I know how to do more with our effects system than I do with our code, so of course I made it with effects. The basic gist of the mini-map effect is that it is several sprites bolted to the camera. I used planar curve input operators that compare the character's position to the world's origin in X and Y. These drive transforms with a ratio derived from the size of the top-down level view to offset the position of the arrow. Rotation of the arrow is handled with an angle curve input operator that is synced to the character's orientation. Apply some sprite sorting to get the arrow to always draw on top, and you've got a serviceable prototype minimap. So now that we've seen how awesome it is to work with the operator stack, let's talk about what wasn't so awesome with the new effects system. The operator stack was a huge departure for VFX artists at VV who are intimately familiar with the previous system. There was, and still is, quite a learning curve. The real difference is that it used to be all exposed and laid out for us. Now, however, using the operator stack is somewhat similar to scripting. You might know what effect you want, you just have to figure out how to build the effect you want, and that isn't always clear. With all the freedom of the operator stack, there's really nothing stopping an artist from trying just about anything. While there is a hard limit of operators, which is a lot, you can still end up with some crazy hard to understand stuff. Also, really complex operator stacks require processing power, and that probably requires an optimization pass. The answer here is training, now that we understand things a bit better, and also tools that report how expensive all those operators are. As you probably know, one of the biggest bullet points on the back of a Skylanders game is the fact that the latest iteration works with every toy ever made in the series. That is a lot of characters. So what happens when you have all of these character effects already created in previous systems that now need to work with the operator stack system? You definitely don't want to redo them by hand. Of course, you have to convert them. This was basically done by creating a couple of special operators that duplicated the functionality of the entire previous effect system. This took a bit of time to implement. Also, VFX creation for SuperChargers couldn't halt while the new system was being developed. For a while we had two effect systems running in-game. The ability to edit previous versions of the effect system was slowly removed until it was basically impossible. You then needed to convert an effect to the new system to edit it. This proved confusing to some developers, especially non-VFX artists used to the old system. In the end, all the effects were converted, the old system was removed, folks got training with the new system, and everything worked out swimmingly, as far as you know. I'm not really sure there's a different solution here. It's practically impossible to develop a system as large and complex as visual effects in a vacuum. I think perhaps early education would have eased the transition. What's next for VFX at VV? It's dangerously easy to add new operators to the effects system if we can just get some engineering time, and we've got a whole list of new requests. Since the beginning of the year, we've already got new physics operators and a suite of texture UV operators. We are working to improve workflows, as you can see from some of the updated Tools UI. I'm a firm believer in documentation and making examples that people can look at and tear apart. We can always use more. It would be totally awesome to see a system like the operator stack applied to materials, but that's just a dream I keep repeating to anyone who will listen at Vicarious Visions. Reusability has really become a focus for the effects team moving forward. One thing became clear making effects for SuperChargers: we make way too many one-off effects. This could have been a fault of the system or the game, or that it just wasn't a motivation of the VFX team in general, but for the most part, every effect in the game was special case and used only for a very specific purpose. This ends up consuming the resources of a pretty small team, is error prone, and not easy to make mass changes. So for our next project, as far as VFX are concerned, we are putting an emphasis on reusability. The concept is to make effects more adaptable so they can be used in multiple situations by exposing core tweakables to script. Also, we intend to make the interface for manipulating the exposed parameters easy to use and understand, so the effects can be placed and set up by non-VFX artists. We call this concept VFX archetypes. Here's an example of a VFX archetype called Fire Area. A level designer or an environment artist can add the Fire Area component to an entity placed in game and modify parameters to fit their needs. The controls have been curated so they are easy to understand and there's not a lot of them. We only have color, length, and width. Behind the scenes, this component's parameters are sent to an instance of the effect and are used to drive multiple aspects. The width and length not only modify the spawn area of the flames, the distance between the two opposing corners is used to compute the spawn rate of the particles to keep the density of the flames appropriate for the area. This value is also used to modify the radius of a light operator in the effect. The color parameter drives both the color of the flame sprites and the effect light, but is applied differently in each primitive. Besides ease of use, one of the most important aspects of VFX archetypes is reusability. Because of the way they are set up, archetype instances are incredibly easy to duplicate. A content creator doesn't have to go into the VFX builder, duplicate the effect, modify all the parameters, and then hook that new version up to another entity. All they have to do is clone an entity, and they have quickly gotten a new copy. Because it is an instance of the VFX archetype, each copy can have its own parameters. Another nice thing is that all instances of the archetype are tied to the same effect, so it's possible to make changes to all the place instances by modifying just a single effect. Speaking of changing a single thing to modify several related versions, operators have quite recently been given the functionality to be instanced themselves. This allows us to place an instance of an operator in the same operator stack, a different primitive in the same effect, or a different effect altogether. If you modify the values of any operator instance, the values are applied in all the other locations. We've only begun to scratch the surface for what we can set up with instance operators, but one idea is a control panel for similar effects. For example, all the fire effects of a particular character can have shared properties and then be editable from a single location, the control panel effect. I hope you enjoyed this presentation of the Vicarious Visions operator stack effect system and how it was used in Skylanders SuperChargers. If you have any further questions or comments, you can feel free to send me an email. Thank you, and keep on making cool effects and effect systems.